Hello everyone, welcome to the next tutorial. In this tutorial, I am going to solve some gate problems based on the concept that we studied earlier. Okay, so let's start with the first problem. So this question was asked in GATE 1992, and in this question, it is already given that all the resistances have the value of 1 ohm, and we need to find the value of the current I. Okay, so as you can see, these four resistances are connected with each other in parallel. It means that their equivalent resistance, let's say it is R1, will be equal to the parallel combination of these four resistors, which will be equal to R by 4. Okay. Similarly, the value of the equivalent resistance of these four resistors will also be equal to R in parallel with R in parallel with R in parallel with R, which is equal to your R by 4. Okay. So now on simplifying the above network, we are getting this. So the value of each of these resistors will be equal to 1 ohm, except these two resistors, which have a value of R by 4, which will be equal to your 1 by 4 ohms. So it will be equal to 1 by 4 ohm each. Also, in the circuit, you can also see that these two resistors are connected in parallel. It means that their equivalent resistance will be equal to 1 in parallel with 1, which is equal to 1 by 2 ohms. Similarly, the equivalent resistance of these two resistor combination will also be equal to 1 by 2 ohms. Okay. So on further simplifying it, we are getting this diagram, and this will be 1 ohm resistor, this will be 1 by 2, 1 by 4, 1 by 2 and 1 by 4. Now as you can see, these three resistors are connected in series. It means that their equivalent resistance will be equal to the series combination of these three resistors, which will be equal to 1 plus 1 by 2 plus 1 by 4, which is coming out to be your 7 by 4 ohms. Similarly, the series combination of these three resistors will also be equal to, R equivalent will be equal to 7 by 4 ohms. Okay. And these two branches are connected in parallel with each other. It means that their parallel combination will be equal to 7 by 4 in parallel with 7 by 4, which is equal to your 7 by 8 ohms. Okay. So, and their parallel combination is connected in series with this resistor. It means that the total equivalent resistance of the above network will be equal to 1 plus 7 by 8, which is equal to 15 by 8 ohms. Okay. So it means that the current flowing in this branch I will be equal to V by R, which is already given. The value of voltage is already given to us, which is equal to 1 volt, and the R equivalent is 15 by 8 ohms. So the value of the current I flowing in the circuit is equal to 8 by 15 amperes. Okay. So I hope it is clear how we are approaching the problem. So let's solve the second problem. And this question was asked in GATE 1999. And in this circuit, and in this problem, we need to find the value of the equivalent capacitance between the terminals B and Y. Okay. So let's say this node is your node A. So as you can see, since this branch is connected to this node, it means that this node will also be equal to A. Similarly, this node is also equal to A. As you can see, the capacitance CC and CS are connected between the same nodes, which are A and Y. It means that these two capacitances are both connected in parallel with each other. It means that their equivalent capacitance C equivalent is equal to the parallel combination of these two capacitors, which is equal to CC plus CS. Okay. Similarly, the capacitance, these two capacitors are also connected between the same nodes. Hence, the equivalent capacitance let's say C equal to is also equal to C plus CS. Okay. On simplifying this diagram, we are getting this network. So as you can see, these two capacitors are connected in series. It means that their equivalent capacitance will be equal to CC plus CS upon 2. Okay. And their combination is connected in parallel with the capacitor CC. It means that the equivalent capacitance of the above network will be equal to CC plus CS upon 2 plus CC, which is coming out to be your 3CC plus CS upon 2. So I hope it is clear how we are solving this problem. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.